In this video, I'm going to be talking about the fundamental gas laws, and as I'm doing these examples, I'm going to annotate the context given to us, and I really recommend you to do the same as you're doing your own problems. Okay, so our first example says a balloon has a volume of 2.0 liters, which is our V1, when the pressure is 1 atm. So that's P1. If the pressure is increased to 2 atm, P2, while keeping the temperature constant, what will the new volume V2 of the balloon be? So given the context, the context given to us, we know that we're going to have to use the Boyle's law, which states that P1 V1 equals P2 V2. And if we do the substitution, 1 atm times 2.0 liters equals 2.0 atm times V2, which is unknown. If you do the isolation, you would get 1.0 liters. So that means our new volume of the balloon would be 1.0 liters. And remember that the Boyle's law states that there is an inverse relationship between the pressure and the volume. So this makes sense. Okay, so our next example says a container of gas has a volume of 10 liters, which is V1, at a temperature of 300 kelvins. T1. If the temperature is increased to 500 kelvins, T2, while keeping the pressure constant, what will the new volume of the gas be? So given the context, we know that this is going to be a Charles law question. And the Charles law states that V1 over T1 equals V2 over T2. If we do some substitution, we get 10.0 liters over 300 kelvins. So usually in a question like this, you wouldn't be given the Kelvin temperature, but most of the time you're going to be given the Celsius temperature, but you are expected to know that you have to add 273 to the Celsius in order to get the Kelvin temperature. That equals V2 over 500 Kelvin. And we're asked what is the new volume, so V2 is unknown. If we do some isolation and if you perform the calculation on your calculator, you should get V2 equals 16.7 liters. So the new volume of the gas is 16.7 liters. Okay, our third example says a sealed flask contains a gas at a pressure of 1.5 atm, so that's P1, at a temperature of 25.0 Celsius or 298 Kelvin, so that's T1. If the flask is heated to 100 Celsius, T2, 373 Kelvin, what is the new pressure inside the flask? So our pressure is unknown, so P2 is unknown. And this is the Gay-Lussac's law, and which states that P1 over T1 equals P2 over T2. And if you do some substitution and if you perform the operation on your calculator, you would get 1.5 atm over 298 Kelvin equals P2 over 373 Kelvin. For P2, you would get 1.88 atm, which is the new pressure inside the flask. Okay, so for our fourth example, a container holds 0.5 moles of a nitrogen gas, which is N1, and has a volume of 12.0 liters, which is V1, at a certain temperature and pressure. If 1.0 mole of hydrogen gas is added to the container, which might look like it's N2, but it's actually 0.5 plus 1 mole, which is 1.5. is added to the container at the same temperature or pressure, what is the new volume? So V2 is unknown. So this would be the Avogadro's law, Avogadro, which states that V1 over N1 is V2 over N2, which is 12.0 liter over 0.5 mole, which equals to V2 over 1.5 mole. And if you do this operation, you should get V2 equals 36.0 liter. So our new volume is 36.0 after adding 1 mole of the nitrogen gas to the container. Okay, our last example says what is the pressure exerted by 1.0 moles of hydrogen gas and in a 5.0 liter container at a temperature of 27.0 degrees Celsius or 300 Kelvin, and we are given the R value. So given these information, we know that this is an ideal gas law, which states that PV equals nRT. And if you isolate for P, you get P equals nRT over V, which is 0.10 mole times 0.0821 L ATM over mole of K times 300 Kelvin all over 5.0 liters. And if you perform this operation on your calculator, you would get P equals 0.49 ATM. So 0.49 ATM is the pressure exerted by all these conditions, and that's it.